All right, worksheet here, second law practice. At the beginning here, we have two paragraphs that go through some notes, concepts, talking about Newton's second law, giving information behind that. And then we have concept practice. So Bob and Sally, they meet at H-E-B. Bob has a full grocery cart, Sally has an empty grocery cart. When they start to move together, who will have to push with more force to get their cart to move? All right, getting it to move. Now, you hopefully inherently know the answer to that, but I want you to explain why. Using Newton's second law. So you need to include the words force, mass, and acceleration in your explanation. If you try to imagine yourself as Bob or Sally, so first imagine being Bob, and then imagine being Sally. And when do you have to use more force to get the cart moving? Okay? Now a little thing here, to get the cart to move, that means you have an initial velocity of 0 and then a final velocity that's faster, okay? Even though it's not much. So when this is happening, getting a cart to move, we're accelerating the cart. Okay, so that's how you're going to use the word acceleration or accelerate or accelerating in your explanation. Okay? So, who, hopefully you already have in your head now, the person who's pushed with more force is Bob. Now, explain how or explain why. Pause the video and give me your full explanation using the words force, mass, and acceleration. Full sentence answers. Your answer shouldn't take more than a sentence or two. All right? So we have here the fact that Bob and Sally are moving together. They're going to have the same acceleration. So, for Bob and Sally to accelerate together, meaning they have the same acceleration, Bob will need to apply a larger force or a greater force than Sally because Bob's cart has a greater mass. Okay? So we explain it using Newton's third law. Accelerate, force, mass. All right, scenario number 2. Now Bob and Sally are both pushing their carts really fast and need to suddenly stop. So they're pushing really fast and then suddenly like someone steps out in front of them with their cart. Okay? They need to stop very quickly. Who will have to apply more pulling force to stop quickly? Explain why using Newton's second law. So use the words force, mass, and acceleration. But instead of acceleration, because in this case they're not accelerating, they're actually decelerating. Remember, deceleration is just negative acceleration. So using the words force, mass, and deceleration, explain who has to apply more pulling force to stop quickly. So picture yourself as Sally and Bob. Picture yourself moving very quickly with an empty grocery cart, and then trying to stop almost as fast as you possibly can, almost instantly, and doing the same thing with a heavy grocery cart. If you're having difficulty conceptualizing this, imagine a semi-truck and a car. Which one stops faster? Okay? So, the one who needs to apply more force to stop is going to be Bob. Alright? So pause the video and explain using force, mass, and deceleration in your sentence. Alright, so for our explanation, for Bob and Sally to decelerate quickly at the same rate, Bob will need to apply more pulling force than Sally because his cart has more mass. So here we have decelerate, force, and mass. Full sentence explanation by why Bob has to apply more force. Third one, now they're in the parking lot and they decide they're going to race. So they both start at rest and they're going to go faster and faster and faster and faster and then cross the finish line. Okay? Pretend Bob and Sally have equal strength. So equal force is applied to both carts during the race. Who wins the race? Okay, so in this scenario, if you think it through, if the carts are a little confusing, maybe consider two pickup trucks. One of them, two identical pickup trucks, but one's empty and one's loaded down with a whole bunch of stuff in the back. All right, which one's going to win the race? Well, hopefully it's obvious that the one that wins the race is the one with less mass. So, pause and give me a full sentence explanation using the words force, mass, and acceleration to explain who wins the race. All right. So Bob, Sally will win the race because her cart has less mass. She will accelerate faster when she applies the same force as Bob applies to his cart with more mass. So if she accelerates faster, she'll get to a higher velocity faster, and the faster velocity wins the race. Okay? So here we go. We use the words mass, accelerate, and force to explain why Sally wins the race. Alright, the last two scenarios aren't really Bob versus Sally anymore. Okay? Now we're trying to compare friction. Friction of surfaces. So a smooth floor of HEB compared to the rough parking lot. So, where is more force applied? For this last scenario, this last situation, compare the friction of the smooth floor of HEB and the rough paved parking lot. So we're not doing a Bob versus Sally anymore. We're comparing smooth floor versus rough paved parking lot. Okay? So first it asks, where is more applied force? So applied force, that's the pushing on the cart. Where is more applied force required to accelerate the cart? In HEB or in the parking lot? And to justify your answer, explain the forces involved. Okay? And then the other one, where is more more applied force required to decelerate the cart? And explain describing the forces. So first, I want to accelerate the cart. So accelerate, it's stopped, and then speed up. Where is that going to require more applied force? Pause before you go ahead and attempt that sentence to explain and describe the forces involved with accelerating the cart. The rough, high-friction parking lot surface resists the applied force, resulting in a decrease in net force. So if you picture this is the cart, here you have the applied force, here you have the friction. Okay, so your net force is going to be small. Now, where is more force applied? Sorry, more applied force required to decelerate the cart. Pause. Complete sentence answer. Okay, more force is required to decelerate the cart. All right, this one is probably the most challenging question on here. So, might be easier to think about if I have the two carts, so a cart on a smooth surface and a cart on a rough surface, and it's already moving with a constant velocity, you just let it go and let it stop all on its own. All right, the smooth floor in HEB is kind of like a bowling ball. It just kind of keeps going. Whereas the rough paved parking lot bounces around a lot, makes a lot of noise, and quickly comes to a stop. So, more applied force to decelerate the cart, to get the cart to slow down, is actually required inside HEB on the smooth floor. Okay? The smooth, low friction floor in HEB does not help decrease the forward velocity as much as the rough paved surface. Okay, so sometimes this is easier to understand with a free body diagram. So here we have the object, okay? Let's say it's moving that direction, so that's its velocity. Okay, and friction, okay, the pulling, all right, this is the force applied, trying to get it to stop. And this is the friction on a low friction floor. So the amount of force working together to slow it down is just a little bit more than the force applied. But if it was a really high friction surface, that'd be a really long arrow, and this would decrease much faster. So that's kind of how that idea works. The idea is most important. Don't worry about the details and like being able to come up with examples. Just understand, and you're probably fine. All right, now for the backside. Attempt all the calculations first and then check them here. Here we go. So calculation practice, this is just good old problem solving process. Kind of preset things up for you. Calculate the force of 45 kilogram bicycle bicycles and bike that accelerate at 3.2 meters per second squared. Okay, so 45 kilograms, is that force, mass, or acceleration? Well, kilograms, that's mass. 45 kg. And then 3.2 meters per second squared measures acceleration. So 3.2 meters per second squared. And then the question is asking for the force. So if the question is asking for the force, we do not need to rearrange. So we're just going to plug in our numbers. 45 times 3.2, and my calculator. $144. So 144 is what the calculator says. Two significant figures, so 140 force measured in newtons. Number two, again, of course, make sure you've done these first, and then you're just checking your answers. All right, 1,200 kilograms. Kilograms measures mass. 6.1 meters per second squared. That measures acceleration. Force is the question. If force is the question, I do not need to rearrange. Mass 1,200 times acceleration 6.1. 1,200 times 6.1. Calculator says 7,320. We need only two significant figures. So that 20 we're going to round up to 7,300. Should I run down to 7,300? Force measured in newtons. Okay. Calculate the mass of a person using 187.5 newtons. That's force. To accelerate, 2.5 meters per second squared is my acceleration. Question is asking for mass. Question is mass. Then we're going to rearrange this formula. So magic triangle, M and A side by side. That puts F on top. And if M is the question, cover M, F over A. So I need to do force divided by the acceleration. So plug in my numbers. My force, 187.5, divided by my acceleration, 2.5. 187.5 divided by 2.5 in my calculator. Make sure line, there we go. 75, calculator says 75. Significant figures, that has 1, 2, 3, 4. That one has 2, so mass should have 2. 2, mass measured in kilograms, 72 kilograms. And last but not least, 7.3 kilograms, that's your mass. So bowling ball pushed 6.4 newtons of force, 6.4 newtons, and the acceleration is the question. Acceleration is the question, so I need to rearrange. M and A side by side, F on top. A is equal to, cover it up, F over M, F over M. So my force, 6.4 divided by my mass, 7.3. 6.4 divided by 7.3. 0.8, so calculator says 0.876713. Significant figures, 2 and 2, so 2 significant figures, 0.88. Acceleration units, meters per second squared. So there's math. Check your calculations, make sure you've got it right. Pretty straightforward calculations with Newton's second law.